So first of all, let me thank everybody for coming out tonight. We're trying something new. Yes, we have had many meetings here in the planetarium, but for the most part, it's only been because the lobby has been unavailable, except for Dave. We have only used the projector. Tonight, I'm going to make full use of the capabilities of the space. I developed the program, well, me and a lot of AI. So if you fall asleep, don't blame Dave, blame me. So instead of the usual list of conjunctions and occultations, my talk will focus on deep sky objects. But before I get to that, I do want to mention the moon. In February, it is known by many cultures as the snow moon, a name rooted in the deep winter sky of North America. The Chippewa called it the bear moon, marking the time when bears begin to stir in their dens. In medieval Europe, it was the storm moon, a reminder of winter's final fury. As the lights fade around you, allow your eyes to gently adjust to the darkness. This moment of shifting from light to shadow is something humans have experienced for countless generations, long before electricity, long before cities, long before the glow of screens filled our nights. Darkness was the natural state of the world. And in that darkness, the sky revealed itself in a way that is almost impossible to see today. Tonight, inside this dome, we recreate that experience. A February sky, untouched by light pollution, stretches above you. A sky filled with stars that shine with the clarity most of us rarely witness anymore. As your eyes adapt, you'll notice more and more stars emerging from the darkness, like distant embers glowing across the cosmic landscape. Let the dome become your horizon. Let the stars settle into your vision. Let's quickly trace the most important asterism in the sky, the winter hexagon. It is served as a celestial compass for cultures around the world. Our first stop is Rigel, a blue supergiant marking Orion's foot, a luminous star visible to the naked eye, tens of thousands of times brighter than our sun. Its light has traveled more than 800 years to reach us. Next is Aldebaran, the red giant eye of Taurus the bull. High overhead shines Capella, a bright yellow star, and Auriga. Capella is actually a system of 4 stars, 2 large giants with 2 smaller companions. It's revered by the Greeks as the she-goat who nursed the infant Zeus. In China, it is part of the 5 chariots, a celestial procession symbolizing imperial authority. Next, the twin stars Pollux and Castor in Gemini. Pollux is a giant star, while Castor is a complex system of 6 gravitationally bound stars. Next to that, Procyon, a binary system, the brightest star in the constellation of Canis Minor, and the 8th brightest star in the night sky. And finally, Sirius, the brightest star in the night sky. It is also one of our closest stellar neighbors, only 8.5 light years away. In ancient Egypt, Sirius, or Sopdet, heralded the flooding of the Nile and renewal of life. Its heliacal, rising, rising marked the Egyptian New Year and the beginning of the agricultural cycle. Together, these stars form a vast celestial frame that defines the February sky. The star's heliacal rising will occur when the Earth has moved to a point in its orbit where the star appears on the eastern horizon at dawn. Within the winter hexagon lie the great constellations of February, constellations that have inspired stories, guided travelers, and served as markers of the changing seasons for thousands of years.
Shall we draw that out, Steve?
Yes. And here is the winter hexagon.
Skipped over Pollux, but that's okay.
Well, Castor or Pollux. Yes. Definitely equilateral. Not.
I've also heard that referred to as the lozenge.
Well, that's funny. Within the winter hexagon lies great constellations. I read this already. Orion the Hunter stands at the center. To the ancient Babylonians of the late Bronze Age, this season marked the return of the great celestial hunter they called Sipzi-Ana, the true shepherd of Anu, or heavenly shepherd. In Greece, he became Orion, a figure of strength and tragedy. Far across the Pacific, the Polynesian navigators read these same stars as part of a vast oceanic map, guiding canoes across thousands of miles of open water. In the Arctic, the Inuit saw not a hunter, but a group of men chasing a polar bear across the sky. Tonight, we join the lineage of skywatchers. The winter constellations rise crisp and bright, inviting us to explore not only the science of the cosmos, but the stories humanity has carried through the ages. North and west of Orion is Taurus, the bull. The V-shaped Hydra's cluster forming the bull's face, with Aldebaran glowing eye as glowing as one of its eyes. High overhead is Auriga, the charioteer. The constellation got this name because its major stars form a shape similar to that of the pointed helmet of a charioteer. To the east is Gemini, the twin, with its stars Pollux and Castor, marking their heads beneath by star clusters, nebula, and remnants of ancient stellar events. Below Orion are Canis Major and Canis Minor, the celestial dogs that accompany the hunter across the sky. And finally, stretching faintly across the sky is Monoceros, the unicorn. Showing.
It's in this region. Very faint stars.
Within Orion lies its belt, the three stars that form one of the most recognizable asterisms in the night sky. From left to right, Alnitak, a triple star system, is taken from the Arabic the girdle, Alnilam, a massive blue supergiant, which is its center star, Manitak, a wide double star, or in some cases they think it's a quintuple star system, some 1,200 light years from the sun. In Armenia, it is known as Hartasu, or Three Brothers, and served as a marker for farming and weather patterns. Near Alnitak lies the Flame Nebula, a dramatic region of glowing hydrogen gas. Its fiery appearance comes from ultraviolet light emanated by nearby massive stars, which ionize the surrounding gas and cause it to glow.
And this image, by the way, this is Alnitak. This is the point.
Thank you. Dark lanes of dust cut through the nebula, creating the appearance of flickering flames. Just below the Flame Nebula is another iconic dark nebula in the sky, the Horsehead Nebula. The Horsehead is not a glowing cloud, but a silhouette, a dense column of cold gas and dust blocking the bright red emission nebula behind it. It's a stellar nursery where gravity is slowly pulling material together to form new stars. The Horsehead's distinctive shape is a reminder that the universe is filled with structures sculpted by radiation, winds, and time. Below the belt lies Orion's sword, a vertical chain of stars and nebulae, a vast molecular cloud complex, a massive reservoir of gas and dust stretching hundreds of light years across. Within its cloud, stars are forming at an extraordinary rate. Nearby that is the Running Man Nebula, a combination of reflection and emission. The blue glow comes from starlight reflecting off dust grains, while the red regions are caused by ionized hydrogen. It is a reminder that nebulas are not formed, they are complex, layered structures shaped by the stars within and around them. Now we arrive at the centerpiece of the winter sky, the Orion Nebula. It is one of the closest and most active star-forming regions to Earth, located 1,300 light years away. Inside this glowing cloud of gas and dust, thousands of young stars are being born. At the heart of the nebula lies the Trapezium cluster, a group of massive hot stars whose intense radiation illuminates the surrounding gas. These stars are only a few million years old, cosmic infants, and their energy shapes the entire region. Within the swirling clouds, astronomers have detected protoplanetary disks, the early stages of solar systems like our own. And just above M42 is M43, a smaller but equally beautiful nebula separated from the main Orion Nebula by a dark lane of dust. It is illuminated by a single massive star, creating that glowing sphere of ionized gas we love to image. As we pull back, a vast arc of glowing gas becomes visible, Barnard's Loop. This enormous structure spans more than 10 degrees of sky and is believed to be the remnant of an ancient supernova explosion. Barnard's Loop is a reminder that Orion is not just a constellation, it's the visible edge of a massive, dynamic star-forming complex. Next to that is M78, another bright reflection nebula, illuminated by young hot stars. Again, its blue glow comes from starlight scattering off dust grains, the same process that makes the Earth's sky blue. Contains several young stellar objects and protostars still in the earliest stages of formation. Before we leave Orion, let's take a moment to appreciate its brightest stars. Betelgeuse, the red supergiant at Orion's shoulder. It is nearing the end of its life. It has expanded to hundreds of times the size of our sun and will one day explode as a supernova. Comes from the Arabic meaning the armpit of the giant. Interesting. Medieval Islamic astronomers charted its brightness with remarkable precision, noting its subtle changes long before modern instruments. In Japan, Betelgeuse is part of the Heike Boshi, a celestial retelling of the Heike clan's fall from power. In indigenous Australia, the star is often linked to the stories of fire, passion, or conflict, fitting for a supergiant nearing its explosive end. Next is Rigel, the blue supergiant in Orion's knee. Another luminous star visible to the naked eye. Safe, the star opposite Rigel, is another hot, massive star nearing the end of its life. Together, these stars form a stellar family that illuminate and shape the Orion region. From here, let's follow Orion's gaze towards the constellation Taurus, where ancient star clusters and shimmering nebula await. In Taurus, Taurus, the constellation, has been recognized for thousands of years. Ancient civilizations carved its form into stone, painted it on cave walls, and used it as a seasonal marker for planting and harvesting. In February, Taurus stands high in the evening sky, stars crisp and clear against the winter darkness. The bull's face is unmistakable, a V-shaped pattern of stars pointing downward, anchored by a bright orange star that glows like a cosmic ember. That is Aldebaran, the fiery eye of the bull. Aldebaran is a red giant, another star nearing the later stages of life. Although it appears to be part of the V-shaped cluster, it is actually much closer to us, a foreground star shining through the Hyades. Its name comes from the ancient word meaning the follower, because Aldebaran appears to follow the Pleiades across the sky. For thousands of years, the star has been a celestial landmark, guiding travelers and marking the changing seasons. Surrounding Aldebaran is the Hyades cluster, the closest open star cluster to Earth, only about 150 light years away. Its proximity makes the Hyades a cornerstone of stellar astronomy. Because its stars are all roughly the same age and distance, astronomers use the Hyades to calibrate models of stellar evolution. They are a gravitationally bound family of stars born from the same cloud of gas and dust hundreds of millions of years ago. Yet, over time, this cluster has stretched and elongated, its stars slowly drifting apart as they orbit the galaxy. Also, the V shape you see is not a perfect triangle. It is a three-dimensional structure with stars at different depths and distances. It's only from Earth that the Hyades form its distinctive V shape. Above the Hyades lies the famous and beautiful star cluster in the entire sky, a cluster so bright, so distinctive, and so deeply woven into human culture that it appears in myths from nearly every civilization on Earth. These are the Pleiades, or more commonly referred to as the Seven Sisters. The Pleiades, or M45 by its Messier designation, is a group of hot young blue stars only around 100 million years old. They shine with a bright white light, illuminating the faint dust clouds that surround them. They are not embedded in this dust, they are passing through it. The blue glow you see is reflection nebula, created as starlight scatters off tiny grains of interstellar dust. The cluster contains more than 1,000 stars, though only a handful are visible to the naked eye. In dark skies, most people can see 6 or 7. Some cultures claim to see more, and many myths explain why one of the sisters is hidden or lost. Nearly every culture on Earth has a story about these stars, a remarkable clue that humans have been watching them since before our ancestors migrated out of Africa. In Greek mythology, they were 7 daughters of Atlas, pursued across the heavens by Orion. In Japan, they are Subaru, a symbol of unity and gathering. The Maori call them the Matariki, whose rising marks the new year and the time of remembrance. The Kiowa, the people of North America, tell of 7 sisters who fled a pursuing bear. The Great Spirit lifted them into the sky, and the bear's claw carved out the marks we now call Devil's Tower. Taurus is not just a constellation of bright stars, it is home to one of the closest star-forming regions, the Taurus molecular cloud. The vast complex of cold gas and dust stretches across the constellation, forming dark lanes and patches that block the light of background stars. Within these dark clouds, gravity is slowly pulling material together to form new stars. The Taurus molecular cloud contains protostars, young stellar objects, protoplanetary disks, dense cores on the verge of collapse. It is a window into the earliest stages of star formation, a glimpse of what our sun may have looked like billions of years ago. Medieval, in the constellation of Taurus lies the faint, ghostly cloud, Crab Nebula, the remnant of a star that died in spectacular explosion nearly 1,000 years ago. In July of the year 1054, people around the world looked up and saw a new star blazing in the sky. Chinese court astronomers recorded it as if a guest star so bright that it was visible in the daytime for 23 days. Japanese observers noted its brilliance. The ancestral pueblos of American Southwest may have depicted it in a rock art, a crescent moon beside a radiant star, just as the sky appeared on the night of the explosion. Medieval European chronicles, however, are strangely silent, perhaps overshadowed by political and religious turmoil, but the event was unmistakable. A massive star collapsed, detonated, and hurled its outer cores into space at millions of miles per hour. Today, we see the expanding debris as the Crab Nebula. At its center spins a neutron star, a city-sized sphere of ultra-dense matter rotating 30 times per second. It pulses like a cosmic lighthouse, a reminder that even in death, stars can illuminate the universe. Long before the Greeks named it, Taurus appeared in the star lore of the Sumerians, the Akkadians, and the ancient Indus Valley. To the Babylonians, this region of the sky marked the bull of heaven, a creature of immense power. In Egypt, the bull was linked to fertility and kingship. In Greece, Taurus became the form Zeus took when he carried Europa across the sea. But the bull's significance may stretch even deeper into prehistory. Some scholars believe that the famous Lascaux cave paintings with their prominent bull and cluster of dots represents Taurus and the Pleiades as they appeared in the sky some 17,000 years ago. If this is true, this constellation is not just ancient, it's primordial. At the heart of Taurus glows Aldebaran, the fiery red giant. It's named from the Arabic, meaning the follower, because it appears to chase Pleiades across the sky. The ancient Greek sailors used the Hyades as a weather omen. Their rising was said to bring rain, and their name may have come from Hyen, to rain. In Rome, they were called the rainy stars. In China, this region belonged to the net mansion, part of a celestial hunting scene. The star Elnath, marking the tip of Taurus's northern horn, up there, it's hot blue-white giant. It lies on the border between Taurus and Auriga and serves as the bridge between the constellations. The horns of Taurus point towards the winter Milky Way, a reminder that this region of sky is rich with clusters, nebula, and star-forming regions. The tip of the other horn, I like to abbreviate A Heka, as in it's a heck of a name to pronounce, and I'll leave that for Dave.
Oh, sure, I can fish at you too.
Yeah, rolls trippingly off the tongue. One more time with feeling.
10 years.
Yeah, one more time with feeling.
Sure, I can fish at you.
All right, we'll let it go. Taurus is a constellation of contrasts, ancient clusters, newborn stars, and remnants of long dead giants. From here, we follow the curve of the winter Milky Way into Auriga, a constellation overflowing with star clusters that sparkle like jewels against the dark winter sky. Rising high above the winter constellation, again, is Auriga, the charioteer, a figure whose origin stretched deep into the ancient world. The Greeks imagined him as Erythonius, the shepherd child, a legendary king of Athens who invented the four-horse chariot. Zeus, impressed by his ingenuity, placed him among the stars. But Auriga's story is older still. In Mesopotamia, this region of the sky was associated with a goat herd or shepherd of the sky, a guardian figure who watched over flocks and travelers. In China, these stars form part of the five chariots, a celestial procession symbolizing imperial authority and the order of heaven. It's a constellation of guardianship, innovation, protection, a reminder that the sky was once a map of human values as much as celestial objects. It is home to three open clusters, M36, M37, and M38, each one glittering island of stars suspended in the Milky Way.
So I'd like to point out kind of where these are. I can't bring them all up at once because they would overlap on each other. And they're kind of out of sequence. So if you find Capella in the sky, look down, 36, 37, 38, this region, if you have a pair of binoculars, you can simply swing it back and forth and you'll see these three open clusters. So I'll bring them up towards the front.
Go ahead. Okay. Well, let's begin with M.
They're sequential, so 36, 37, 38.
And 36 is a young cluster, about 4,000 light years away. Excuse me a second. Its stars are hot, blue, and energetic. It is often compared to the Pleiades, though it lies much farther away and is embedded in a richer star field. Next is M37, the richest and most densely populated of the three. It contains more than 500 stars and glows with a warm golden light from many of its red stars. This cluster is a beautiful example of how star clusters evolve over time, with stars of different masses aging at different rates. Finally, M38, a broad, loosely structured cluster with its distinctive cross-shaped pattern. Its stars are older, more widely spaced, giving the cluster a delicate, airy appearance. Together, these clusters form a stellar triptych, a sequence of ages and stages in the life of star clusters. Near the Auriga clusters lies a dramatic and colorful region known as the Flaming Star Nebula, or IC 405. And there it is. This nebula glows with a mixture of red emission and blue reflection light. The red comes from the hydrogen gas energized by hot, massive stars, and the blue, again, from the scattering of dust grains. The star responsible for this glow is AE Aurigae, a runaway star ejected from its birthplace millions of years ago and now racing through space at high speed as it plows through the surrounding gas, lighting up the nebula like a torch moving through fog. Nearby lies another remarkable region, the Tadpole Nebula. This glowing cloud of gas and dust is home to a young star cluster, NGC 1893, whose hot massive stars illuminate the surrounding nebula. Within IC 410 are two elongated structures known as the tadpoles, dense clumps of gas being sculpted by stellar winds and radiation. These structures may one day collapse to form new stars. This region is a vivid example of how stars shape their environment, carving, compressing, and illuminating the clouds from which they were born. From the cluster-rich fields of Auriga, we drift eastward into the constellation Gemini. Gemini is marked by two bright stars, Castor and Pollux, standing side by side like celestial sentinels. Pollux, the brighter of the two, is an orange giant, while Castor, though slightly fainter, is far more complex. Six stars. It's a six-star system composed of three pairs of stars orbiting one another. These two stars have been associated with twins, heroes, and protectors in cultures around the world. In February, they stand high in the sky, marking the gateway to some of the season's most beautiful clusters. In Greek mythology, Castor was mortal and Pollux divine. When Castor was killed, Pollux begged Zeus to let them share immortality. The king of the gods placed them in the sky, forever side by side. Their constellation became a symbol of brotherhood and protection. Sailors prayed to them for safe passage across stormy seas.
Steve,
But-
I'd like to just point something out. They do
Sure.
look like twins. Here's Castor, Pollux. If you look above each one of them, you'll see a fainter star. So if you think about it, each one looks like a pair of eyes here. And then they're kind of symmetrical. So you can kind of make out a twin pair.
Thank you. But the twins appear far beyond Greece. In ancient Babylon, this region represented the great twins, guardians of the cosmic order. In Vedic tradition, they echo the Ashvims, divine horsemen who brought healing and rescue. Among the Maya, twin heroes appeared in the Popol Vuh, descending into the underworld to defeat the lords of death. Human cultures, separated by oceans and millennia, all imagined powerful twins, a testament to how deeply the night sky has shaped and shared our storytelling instincts. Near the feet of the twins lies M35, a rich open cluster containing hundreds of stars. Its stars are relatively young, bright, blue-white, and scattered across a wide field. Besides M35 lies a much older and more distant cluster, NGC 2158. Though it appears faint and compact, NGC 2158 contains thousands of stars and lies more than 5 times further away than M35. Together, these two star clusters form a striking contrast, a young nearby cluster besides an ancient distant one. They are a reminder that the Milky Way is layered with stars at many distances and ages. Still farther east lies a small but fascinating object, the Eskimo Nebula, or NGC 2392. It is a planetary nebula, the glowing shell of gas ejected by a dying star. At its center lies a hot white dwarf, the exposed core of the star that once was. The surrounding gas forms intricate layers shaped by stellar winds and magnetic fields. The planetary nebula, like this one, are brief, beautiful phases in the life cycle of sun-like stars. As we drift southward, the bright stars of Gemini, I'll start again. As we drift southward from the bright stars of Gemini, we enter one of the most quietly spectacular regions of the sky, the constellation Monoceros, the unicorn. Monoceros is faint. Its stars are subtle, easily overshadowed by the brilliance of Orion and the winter hexagon. But hidden within these unassuming constellations is a treasure trove of nebula, clusters, and star-forming regions. Some of the most beautiful and scientifically important objects of the February sky. Monoceros is a reminder that brightness is not the only measure of significance. Sometimes the faintest regions of the sky contain its richest stories. We begin with the crown jewel of the Milky Way, the Rosette Nebula, a vast circular cloud glowing hydrogen gas spanning more than 100 light years across. The Rosette Nebula is an emission nebula, glowing red from hydrogen atoms energized by the intense ultraviolet radiation of young massive stars. Its shape resembles a cosmic flower, delicate, symmetrical, and breathtakingly large. At the center of the rosette lies the open cluster NGC 2244. A group of hot luminous stars form from the very gas that now surrounds them. These stars are only a few million years old, cosmic infants, and their radiation has carved out a vast cavity in the nebula, pushing the gas outward and sculpting the rosette's distinctive shape. The nebula is a stellar nursery on a grand scale. Within its dense clouds, new stars continue to form, hidden by curtains of dust. Infrared observations reveal dozens of protostars, young stars still gathering mass, still igniting, still finding their place in the galaxy. Just north of the rosette lies another region, the Christmas tree cluster and the Cone Nebula. The Christmas tree cluster, NGC 2264, is a young open cluster whose bright stars form a triangular pattern resembling a tree. The cluster is embedded in a glowing cloud of gas and dust, illuminated by the hot stars within. At its southern tip of the region lies the Cone Nebula, a towering pillar of dark gas silhouetted against a bright background of ionized hydrogen. The cone is shaped by intense radiation from nearby massive stars, which erodes the surrounding gas and sculpts it into dramatic forms. This region is a vivid example of interplay between young stars, the clouds from which they form, a cosmic dance of creation and destruction. Adjacent to the Christmas tree cluster lies the Fox Fir Nebula, a complex region of glowing gas and dark dust lanes. Its intricate texture, a mixture of bright filaments and shadowed ridges, gives it the appearance of soft fur illuminated by starlight. It is part of the same star-forming complex as the Cone Nebula, shaped by the same powerful forces. Together, they form a tapestry of light and shadow that reveals the turbulent environment of stellar birth. Farther south lies the Seagull Nebula. This vast complex of emission and reflection nebula stretches across the border of Monoceros and Canis Major. Its shape resembles a bird in flight, wings outstretched against the dark backdrop of space. The Seagull Nebula is illuminated by several young hot stars embedded within its structure. Its glowing arcs and sweeping curves trace the edges of expanding bubbles of ionized gas sculpted by stellar winds and radiation. Monoceros is also the home to several delicate reflection nebulae, where starlight scatters off dust grains, creating a soft glow. IC 2169 is a faint, wispy nebula illuminated by young stars. IC 447, a broad reflection nebula with intricate dust structures, and IC 446, a compact a compact nebula glowing with a subtle blue sheen.
Sorry. That one.
We forgive you. These nebula are reminders that not all cosmic beauty is bright and bold. Some of the most striking features of the sky are quiet, subtle, and easily overlooked, but no less magnificent. Stretching across a large portion of Monoceros is the Monoceros Loop, a vast and ancient supernova remnant. This faint arc of glowing gas is what remains of a massive star that exploded tens of thousands of years ago. Though difficult to see in visible light, the Monoceros Loop is prominent in radio and X-ray observations. It is a reminder that life cycle of stars is not only about creation, it is also about transformation, recycling, and renewal. As we follow the winter Milky Way southward from the nebula-rich fields of Monoceros, we enter the constellation Canis Major, the great dog. In mythology, Canis Major is the faithful companion of Orion, running at his heels as he hunts across the sky. In astronomy, Canis Major is home to some of the brightest stars, to the brightest star in the night sky, as well as clusters and stars that shine with extraordinary brilliance. This region of the sky is a showcase of stellar extremes, massive blue giants, brilliant clusters, and the dazzling beacon of Sirius. At the heart of Canis Major shines Sirius, the brightest star visible from Earth. Its brilliance is due to a combination of factors. It's intrinsically luminous. It is relatively close, only 8.6 light years away, and it shines with a pure blue-white intensity that cuts through the winter air. Sirius is actually a binary system. Its companion star, Sirius B, is a white dwarf, a dense Earth-sized remnant of a once sun-like star. Sirius B was the first white dwarf ever discovered, providing astronomers with the crucial insights into the final stages of stellar evolution. For thousands of years, Sirius has been a cultural touchstone. Ancient Egyptians used its rising to mark the flooding of the Nile. Sailors navigated by it, and in February, it stands high in the southern sky, anchoring the Great Winter Triangle. Surrounding Sirius are several massive luminous stars that form the body of the Great Dog. Just west of Sirius lies Mirzan, whose name means the herald. It rises shortly before Sirius, announcing its arrival. Farther down is Adhara. If Adhara were as close to Sirius, it would outshine every star in the sky. That's how far away it is. Wesen is a yellow-white supergiant. It's expanding and cooling, preparing for its final stages. At the tail of the Great Dog lies Aludra, another massive star destined to end in a supernova. Together, these stars form a chain of brilliant lights, a stellar parade, marking the path of Orion's celestial companion. Below Sirius lies M41, a bright, open cluster easily visible in binoculars, containing about 100 stars. It's roughly 2,300 light years away and about 200 million years old. These stars form a loose, sparkling pattern against the dark winter sky. Red giants glow warm among younger, bluer stars, creating a beautiful contrast of color and age. It's a reminder that star clusters are families, groups of stars born together, traveling through the galaxy as a unit.
This is also known as the little beehive, as opposed to the big beehive.
And is there a mommy beehive too? You gonna show the actual beehive? Oh,
Well, if you brought your binoculars, you may be able to see this. Good one. Let me dim this down. Do you have them? Right here. You could probably see that, anybody can see that with averted vision. That's the beehive in Cancer.
thank you. Farther east lies the striking cluster in the western sky, NGC 2362, also known as the Tau Canis Majoris cluster. At its center is Tau Cma, a massive, is that how you pronounce it? CMA? A massive luminous star that dominates the cluster. It is so bright that it illuminates the surrounding stars like a cosmic spotlight. NGC 2362 is a young cluster, only a few million years old. Its stars are still in the early stages of their evolution, shining with intense blue-white light of youth. The cluster is a snapshot of stellar infancy, a glimpse of what the Pleiades might have looked like long ago. Oops. Let's go back. Now let's move on to Canis Minor, the little dog. Though small and faint, this constellation contains one of the winter hexagon's stars, Procyon. It is a binary system consisting of a primary star and a. If you've forgotten what the hexagon looks like, we're going to review it for you. Yeah.
I was trying to do the triangle.
Okay.
There.
The Procyon means before the dog because it rises shortly before Sirius. Together, he's getting ahead of himself. Together, Sirius, Betelgeuse, and Procyon form the winter triangle, another prominent asterism in the February sky. Each star represents a different stage of stellar evolution. Sirius, a young, hot star with a white dwarf companion. Betelgeuse, again, a red supergiant nearing the end of its life. And Procyon, a mature star with a white dwarf companion. The winter triangle frames some of the richest regions in the winter Milky Way, guiding us towards the deep southern sky. As we rise from the brilliance of the winter triangle, our path carries us into the constellation Perseus, the hero. Perseus is a constellation rich in mythology, a warrior who rescued Andromeda, defeated Medusa, and rode across the sky on a winged horse, Pegasus. At the heart of Perseus shines Alpha Persei, or Mirfak, in Arabic meaning elbow. Hinalali is the name of the star in native Hawaiian astronomy. It's meant to commemorate a great tsunami and mark the beginning of the migration of the Maui. According to some Hawaiian folklore, Hinali's is the point of separation between the earth and the sky that happened during the creation of the Milky Way. In Chinese, Mirfak and the surrounding stars are referred to as the celestial boat. Mirfak is a bright yellow white star supergiant. It's surrounded by loose association of hot massive stars known as the Perseus OB Association, a sprawling family of young stars born from the same giant molecular cloud. It's a region where stars are born in clusters, drift apart, and eventually disperse across the Milky Way. Nearby is Algol, a well-known variable star. Known as the demon star, Algol dims and brightens every 2.87 days, a cycle so regular that ancient astronomers noticed its strange behavior long before telescopes existed. Algol is eclipsing binary system. Two stars orbit each other so closely that one periodically passes in front of the other, causing the system's brightness to drop. The celestial heartbeat has fascinated observers for centuries. Between Perseus and Cassiopeia lies another breathtaking sight, the double cluster, a pair of open clusters known as NGC 869 and 884. These clusters are young, only about 12 million years old. They lie more than 7,000 light years away. Their stars are hot, blue, and brilliant, shining with the intensity of youth. It is a cosmic jewel box, glittering islands of stars suspended in the Milky Way. Through binoculars or a telescope, the view is spectacular. Hundreds of stars arranged in a delicate pattern with subtle color variations and intricate structure. From the double cluster, we drift into the constellation Cassiopeia, the Queen. Her distinctive W-shaped pattern is very recognizable asterism in the northern sky. She sits opposite the Big Dipper across the North Star, making it a reliable guide for navigation. But beyond its shape, Cassiopeia is rich with star clusters, nebulae, and remnants of ancient stellar events. As we move away from the dense star fields of the Milky Way, the sky begins to thin. The bright, crowded regions of star formations give way to darker, quieter expanses, the perfect backdrop for observing galaxies far beyond our own. In February, the northern sky offers the window into the local group and the galaxies that surround it. Let's begin with probably the best known one, Andromeda Galaxy, or M31. It is our nearest major galaxy and the largest member of our local group. It is a vast spiral galaxy containing more than 1 trillion stars, lies approximately 2.5 million light years away, yet it is visible to the naked eye as faint, elongated smudges. Though through the dome, we can see its sweeping spiral arms, its bright central bulge. Are we showing it?
No, not yet.
Oh, I'll wait.
All right, there you go.
There it is.
That's another binocular object, Bill, by the way. Okay.
Through the dome, we can see its sweeping, now it makes sense, sweeping spiral arms, its bright central bulge, and dust lanes that trace its structure. Andromeda and the Milky Way are on a slow collision course, destined to merge in about 4 billion years. So no holding your breath. Nearby is the Triangulum, I know that word, Triangulum Galaxy, or M33, a delicate spiral galaxy with loosely wound arms. It's smaller than Andromeda, but rich in star-forming regions, with some of the largest known nebula in the galaxy. Faint, diffuse structures makes it a challenge to see with the naked eye, but through the dome, its spiral arms unfold like a cosmic pinwheel. Did you show it? Okay. Further north still is the constellation Camelopardalis. It's large and faint. It's the 18th largest circumpolar constellation, was introduced in 1612 by Tritris Pansius. It represents a camel leopard, the Greek word for giraffe, and fills in the previously empty space between Cassiopeia and Ursa Major. It lacks ancient mythology. It features stars that are less than fourth magnitude and is best viewed during this month. While
For
the
reference here is Ursa Major.
okay, we'll put that up again. I gotta laugh. I gotta laugh. I don't know. I guess seeing a giraffe in the sky must be kind of interesting. It's not referenced to any mythology. The constellation name, though, could be a reference to the book of Genesis in the Bible, but this remains doubtful. When Jacob Bartsch included the constellation on his stellar map in 1624, he described the constellation as a camel on which Rebekah rode into Canaan, where she was to marry Isaac. But since it represents a giraffe and not a camel, it's unlikely that this is the right explanation. Next, we visit the spectacular galactic pair M81 and M82.
Can I just point out where this is first, because I didn't put it where it needs to be, so
Okay.
part of my point here, Big Dipper is here early in the evening, 4 stars in the bowl, and then 1, 2, 3 in the handle. You're going to talk about which deep sky objects?
M81, M82.
Okay, so to find them, you connect this star to that star, come out about the same distance, right here. I'm not gonna bring it up in that location, I'm gonna bring it up towards the front. Sorry, Steve.
That's okay. And that looks like the picture I have here.
Good.
I guess there's only so many ways you can take that image.
81, 82.
81 and 82. A grand design, the M81 or Bode's galaxy is a grand design spiral galaxy with sweeping arms and bright central bulge. M82, the cigar galaxy, a starburst galaxy undergoing intense star formation. Its central region is exploding with activity driven by the interactions with M81. Together, these galaxies form a dramatic pair in the northern sky. Now let us, did I go through them all? Wow. Let us return to Earth, our home, our vantage point, our tiny island in the vastness of space. From orbit, Earth glows with a soft blue light wrapped in a thin atmosphere that protects us and nourishes life. On the night side, the February sky stretches overhead, the same sky we explored tonight, filled with stars, clusters, nebula, and galaxies. Every object we visited, from the Orion Nebula to the Pleiades, from the Rosette to the Seagull, from the double cluster to Andromeda, is visible from this small world if we know where to look. The February sky is a tapestry of cosmic stories, a sky of brilliant stars and ancient clusters, the sky of newborn stars and dying giants, the sky of glowing nebula and distant galaxies. It is the sky that reveals the life cycle of stars from their birth into dark clouds to their explosive deaths. It is a sky that connects us to the universe, not just virtually, but physically. To paraphrase Carl Sagan, the atoms in our bodies were forged in the hearts of the stars like those we saw tonight. We are not separate from the cosmos, we are part of it. So as we slowly raise the house lights, Dave and I want to thank you for joining us on this journey through the February night sky. Next time you're outside trying to capture another 5 hours of a target you've been working on for the past 3 weeks, take a moment to appreciate the great vastness of the stars, nebula, and galaxies, the incredible beauty which is the universe. Remember, the night sky is always above you, waiting to be rediscovered. Each clear night is an invitation to look up, wonder, and explore. Thank you.
Hold on. Here you go.
That was astounding, and I can't believe the kind of research that you've had to do to make this happen. I mean, we're talking weeks. And I also like the poetic sense of it all.
Well, thank you.
That was absolutely first rate. Thank you.
You're very welcome.
Very good.
Let me, I think I lost the mic. Did I lose it? Oh, you turned it down?
It's on again.
Oh, okay. So let me exit this. And do we lose the Zoom? Do we still have it? Are people on Zoom still? I don't.
Yes.
Where'd it go? I don't know.
There they are.
Oh, that came back. Okay. Where is it? All right, we'll stop sharing.